Alright, good morning from Threes. How are you guys doing? How was the weekend? I believe you guys had a great time over the weekend, yeah. Some how to go to church, some how to stay home. Either way, just stay safe, okay? Try our best to stay safe. Until we meet again, I think it'll be on the 8th of February, so yeah, just looking at you a while. Alright, so today we'll proceed with electricity. One that we started looking at, I think, before the schools closed. And we see there are two branches of electricity, electrostatics and current electricity. And we said current electricity simply referred to as electricity. So the electricity that you know, that you hear, usually people refer to electricity as current electricity. It's even scientifically correct. Now, today we'll proceed to look at conventional current. Okay, last time we were looking at electron current, and I said this is a type of current or the flow of charge from the negative terminal of a cell to the positive terminal of the side of the electric circuit. And I said if you want to know which side is the negative side of a cell, just look at a shorter line. There are two lines which are drawn to represent a cell on a circuit diagram on the book or on a paper. So those two lines, the one which looks shorter, it means that side is a negative side, and the one which looks longer, then it simply means that side is a positive side. Yeah. So if we were talking about electron current, it simply means we'd say that current is moving from this side, which has a shorter line, to the other side, which has a longer line. See? So that's electron current. But today I bring a new message. Today I bring a new chapter in your life of currents, the conventional current. It says it is a flow of electric charges from the positive terminal to the negative terminal of the circuit. Those other words were blotted off, but don't worry about it. I made this so I should know what's happening around. Now, if you look at this cell, you can see that the positive side is on top and the negative side is below it. Now, for this reason, it simply means if you talk about conventional current, you talk about the flow of charge from the top side to the side underneath it. In other words, it means current will start flowing from the top side, going up the solid line all the way to where the switch is. Now, this whole thing is happening under the assumption that the switch is closed. Because if you open the switch, then there'll be no flow of current. Yeah, just impossible. Now, so in the end, you're going to have a current which flows in this direction, as you can see. It'll be in the clockwise direction. Simple as that. So that's it about conventional current. And whenever you hear the word current in physics, it means we are talking about conventional current. Okay. So if you hear current in physics, it means we are talking about conventional current, nothing else. We don't talk about electron current anymore. We talk about conventional current. Right. Now, let's talk about measuring current. Just like any other physical quantity, current can be measured. Okay, just like you can measure length, you can measure mass, you can measure time, okay, you can measure all that stuff. The same way you can also measure current. Alright, and to do that, you need an instrument. To measure physical quantities, you need an instrument. And the name of this instrument is ammeter. It's an ammeter. Ammeter if you're American, and ammeter if you're British. So the choice is yours, but that's a spelling, Ammeter. Okay, ammeter, I prefer to say ammeter. Alright, so the circuit symbol for an ammeter is, there is the circuit symbol for an ammeter. So you have a circle and then A inside, alright, and lines moving away from it. It simply means that's, so if you see that in a circuit diagram, it simply means it's an ammeter, and the whole purpose you have in a circuit diagram simply means it is there to measure the current. Yep. So look at the A. So the A means ammeter, I guess, or who knows. But the A should show you that it's an ammeter. So the units of current are amperes or amps. Now, you do know that any physical quantity should have a unit. For example, force, the unit is Newton. Weight, the unit is the same. Mass, the unit is kilogram, and time, the unit is second. Length, the unit is meters. Now, for current, the unit is amperes, and the pronunciation can be taken from there. So I will say amperes, and you guys can call it amperes. We can call it amperes. We can call it amperes. There's no problem. But I like the fact that people realize that it was hard for you to pronounce the unit for current, so they prefer just to cut it to amps. So apparently in class you never hear me say amperes. I'll just be saying amps because I don't want to start a debacle there. All right, so 5 amps, 7 amps, 8.5 amps, 0.3333 amps, just like that. So below we have an ammeter. It looks like this. So if in the lab you see something like this with a scale on it and a moving hand and the letter A, that's the main thing. The letter A on it, simply know that that's an ammeter. Okay, because you have so many of these instruments which look like this but with different letters on them. So for the ammeter you see an A on it, and there you are. You can go ahead and use it. Alright, so let's see how ammeters are connected in a circuit. In a circuit, yes. Ammeters are connected just like that, as you can see, like a bulb. Exactly like a bulb. That's how you connect ammeters. However, you see in practical that ammeters have polarity, that is positive, negative, and that has to be respected. But for the meantime, in drawing, on paper, there's nothing like polarity, whatever it is. You just connect them like that. Alright, now let's look at measuring current in a series circuit. Alright, so current in a series circuit is the same throughout the whole circuit. I know this sounds like, what? But what it means is any ammeter connected to measure current in a series circuit will show the same reading. A good example is this. Yeah. You see, there are 2 ammeters in here. So whatever this ammeter on top is showing, it will be the same as what the other ammeter below it is also showing. That's what happens in a series circuit. So it will be the same. Okay. A good example is this. If the one on top shows 5 amps, it means the one below will also show 5 amps. Just like that. Okay. Right, now that brings us to the end of conventional current, and next time we'll be looking at how we can measure current in a parallel circuit. If you have any questions, whatever it is, just ask. Don't be scared to ask. You can ask through this platform. You can ask in the chat. You can ask, or you can use my phone, whatever it is, as long as your questions reach me and you'll be helped accordingly. Otherwise, have a good day. Yeah, sure. See you in the next lesson.